In this example, I'm looking at rational functions, specifically finding their vertical asymptotes and wholes. So in step 1, I need to factor the numerator and denominator of the rational function. Then, if c is a 0 of a factor of the denominator that cancels, then there is a hole in the graph when x equals c. But if c is a 0 of a factor of the denominator that does not cancel, the graph of the rational function has a vertical asymptote when x equals c. Now looking at my first example over here, does anything factor? Well, looking in the numerator, it's the difference of two squares. That definitely factors. The square root of x squared is x, so I need an x and an x. The square root of 25 is 5, so I need a 5 and a 5. I need opposite signs in my parentheses, so I have x plus 5 times x minus 5. Now looking at the denominator, if it factors, this is an easy one. The leading coefficient of the x squared is a 1. So that's just going to give me an x and an x. Two numbers multiply to a positive, that says the signs are the same. If they add to a positive, that same sign has to be plus. Two numbers that multiply to 2 and add to 3, I only have one choice, 1 and 2. Does that work? Yes. If you're not sure, FOIL this out and you'll land up with this polynomial. So does anything reduce in this expression? No, I have no common factors between the numerator and the denominator. Nothing cancels, therefore I have no wholes. So for wholes, I put none. And now the two factors in the denominator do not cancel, so those are going to produce vertical asymptotes. So you take your denominator and set it equal to 0. Two factors multiplied together equals 0. Set each of them equal to 0. So I have x plus 1 equals 0 and x plus 2 equals 0. From the first one, subtract 1 from both sides. I get x equals negative 1. And the second one, subtract 2 from both sides. X equals negative 2. So the equation of my vertical asymptotes are x equals negative 1 and x equals negative 2. Now remember, vertical asymptotes are equations of lines. You can't say the vertical asymptotes are negative 1 and negative 2. Those are numbers. I have to have the equation of a vertical line which has the form of x equals a number. Now, looking at the next example, let's see if we can factor the numerator. Two terms, they have an x in common, so factoring out an x, it's going to leave me with x minus 4. And looking at the denominator, x squared, so if this factors, I'm just going to have an x and an x. Two numbers multiply to a positive, the signs are the same, but they add to a negative, so both signs have to be negative. Two numbers that multiply to 12 and add to negative 7, I think it's negative 3 and negative 4. Now, in this example, does anything reduce or cancel? Yes, my x minus 4s are common factors of the numerator and the denominator. So my function simplifies to x times 1, which is x, divided by x minus 3 times 1, which is x minus 3, provided that this common factor does not equal 0. Well, x minus 4 equals 0 when x equals positive 4. So we have to put by the simplified version of the function that x cannot equal positive 4. So now, since we had this common factor that canceled out, that is going to give us a whole when x minus 4 equals 0, or when x equals 4. To find the y-coordinate of the whole, we plug 4 into the simplified version of the function. So we're going to get 4 divided by 4 minus 3, which is 4 divided by 4 minus 3 is 1. 4 divided by 1 is 4. So I have a whole at the coordinates 4, 4. And did I have a factor left in the denominator after I simplified it? Yes. That is going to give me a vertical asymptote. And the vertical asymptote is going to be when x minus 3 equals 0. So adding 3 to both sides, I get x equals 3. So that's the equation of the vertical asymptote for this function. Now looking at our last example here, the numerator doesn't factor. How about the denominator? Be careful, this is the sum of two squares. It does not factor. So I have no common factor that can reduce between the numerator and the denominator. So are there any wholes? No, there are none. How about vertical asymptotes? Let's set the denominator equal to 0. I have x squared plus 1 equals 0. It doesn't factor, so solve it by subtracting 1 from both sides. I get x squared equals negative 1. Take the square roots of both sides. X equals plus or minus the square root of negative 1. So x equals plus or minus I. So are there any real solutions for when the denominator equals 0? No. So vertical asymptotes only come from when you get real solutions to the denominator equaling 0. So are there any vertical asymptotes for this example? No, there are none. So this function has no wholes and no vertical asymptotes.